Hi everyone, thank you for joining with this webinar this morning. My name is Hiram Besaidnight and I am an application engineer for micrographics. Today we're going to have a look at Inventor top-down assembly modeling and what that entails. Today's webinar about the top-down assembly modeling is we're going to utilize the layout design method. Now in this webinar we will have a look at Inventor top-down assembly modeling and see how we can utilize the layout environment within Inventor. The agenda today includes an introduction to top-down designing, followed by a basic overview of the approach and a comparison with bottom-up design. A key focus will be on creating layouts, exploring what they involve and the steps required. Additionally, this session will cover building assemblies within Inventor using the layout method, along with creating parts and components based on the layout. The session concludes with a summary. Now, the top-down assembly modeling is a design approach in Autodesk Inventor where you start creating parts within the context of an assembly. This method emphasizes designing components based on their relations and interactions within the overall assembly, allowing for better integration and more efficient updates when design changes occur. Now, when we think about the layout designing, first you work in the assembly environment. You'll create your IPT, that would be your 2D sketch layout, and from there you'll start creating all your components or parts as needed or required for your layout assembly. Now, if we look at an overview of a bottom-up designing, bottom-up design is a method of product development where individual components or parts are created first, and then these are assembled together to form larger sub-assemblies and eventually the complete product. This approach starts with the smallest, most fundamental parts and builds upwards to create the final system. We start creating all our individual parts and then we utilize the assembly environment to create our assembly. Now, this is just an example of what the bottom-up designing method looks like, where you create all your parts individually and then you assemble them together. That is a good example of a bottom-up design. Another method of the top-down assembly would be what we would call a multi-body part. It's, for instance, when you create or you open your assembly environment and you start creating your base part, and then you build each part or component from that base part. Now, that would also cause adaptivity. If we look at the key features of a bottom-up design, we've got the part-centric approach, where each component is designed independently based on its specific functionality and its constraints. We focus on the detail. This design process emphasizes the creation of precise and functional parts before considering the overall system. we've got our component integration. That means once all the parts are designed, they are combined to form sub-assemblies or the full assembly, ensuring they fit and work together. We've got the iterative process. That means adjustments may be needed to be made if individual parts do not integrate smoothly, requiring redesign or modifications of your components. Now we're going to have a look at some of the advantages and disadvantages of bottom-up designing. First, we've got our advantages. We've got modularity, that changes to individual parts can be made without affecting the entire design. That's one of the great advantages. So if a part needs to have any modifications done, you can do so, and it will only affect that specific part, and you can update your assembly. Detailed component development. Now designers can focus on creating optimized and highly functional parts. Flexibility in reuse. Parts can often be reused in different designs or projects. If we look at some of the disadvantages of bottom-up designing, we've got potential for misalignment. Now, since the overall structure isn't considered initially, integrating parts into the complete system may result in compatibility issues, where you can go and see if there's any interference within Inventor, because you've got all your parts, and then you can run what we would call an interference check to see if there's any part that does not fit the way it's supposed to. Limited focus on the big picture. It may be harder to ensure that the final assembly meets overall project goals or design constraints. Now that's dependent on what you want to achieve at the end of the day and your standards and the way you design within your company. We're going to have a look at key features with top-down design. We've got our context-based design, where parts are created within the assembly environment. It ensures components fit and interact seamlessly. We've got the relationship-driven approach, where we focus on the designing of components based on their interaction within the overall assembly. Improved integration, where components are better aligned with the assembly structure. And lastly, we've got the efficient updates. Now, what that entails is the design changes propagate throughout the assembly, minimizing rework and maintaining consistency. Advantages and disadvantages of top-down design. Let's have a look at some of the advantages. First, we've got unified design intent. Since all the parts are derived from the same top-level layout consistency, it's maintained across the design. Fewer integration issues, where components are designed to fit and work together from the start, reducing the risk of assembly problems. Easy updates. Changes made to the top level layout propagate automatically to the individual components, saving time and reducing errors. The biggest advantage is the better big picture control. It allows designers to prioritize overall system requirements and functionality. Some of the disadvantages is the complex initial setup. Creating the top level layouts can require more planning and effort upfront. It does really take quite a lot of planning when you want to build your skeleton model structure, and it really does take up quite a lot of time. Rigid dependencies. Changes to the top level design can affect all downstream components, potentially leading to rework if not managed carefully. Again, it comes down to planning. Less flexibility for standalone parts. Components are often tightly tied to the system, making them harder to reuse in other projects, as it's still linked to this single skeleton model. Best practices for top-down design. We have to plan the design, outline the relationships and dependencies before starting to avoid any unnecessary complexity. That is why we have to plan before we start with the design. Use master sketches wisely, where we need to keep the sketches clean and well organized to simplify updates. Avoid over-referencing. Minimize the dependencies between components to prevent circular references or slow updates. Document parameters and relationships, where we use descriptive names for parameters and sketches to improve the clarity and the collaboration. Key features of the layout design in Inventor. One of them is the master sketch approach, where a 2D sketch is used to define the key geometry, dimensions, and relationship. It acts as a guide for creating and positioning parts in the assembly. Top-down modeling integration, where layouts can serve as the driving framework for the top-down assembly modeling. Components can be created and constrained based on the layout. We've got the adaptive design, as you guys saw, with the multi-body part, where geometry in the layout can drive the size, position, or the shape of the parts, and change the layout, automatically update depending components. We've got our 2D layouts, where initial layouts can be done in 2D sketches. Assembly layout optimization. Now what this actually entails is, before you commit to detailed modeling, you can evaluate the layout for clearances, motion and fit, and adjustments can be made quickly without the overhead of modifying detailed models. Just going to run over the basis of the key features of the layout design, where the master sketch approach, you have to look at the top-down modeling integration. Remember about adaptive design. The most important is your 2D layout, your sketches, and the constraints and geometry that goes with it, and then your assembly layout optimization. Now, utilizing a layout design and define the sketch blocks. Now, sketch blocks in Autodesk Inventor is a grouping of 2D geometry within a layout representing a specified portion of the assembly. Some of the usage is each component in the assembly is defined as a separate sketch block, and sketch blocks can include other sketch blocks, creating nesting sketch blocks to define sub-assemblies. That is when you have two parts that always has to move together or work together. Then you can create a nested sketch block. If we think about creating a layout, to create a layout within the assembly environment, you open a new assembly file, go to the assembly tab, expand the component panel, and then select layout. The layout is automatically added to the active assembly as a grounded component, and a new standard file is generated for the layout. Just to run through on how to create sketch blocks, you select the 2D entities that will make up the sketch blocks. You'll navigate to the sketch contextual tab, and in the layout panel click create block. I'm going to do a small demo for you guys just to show you guys how we would go and create a basic layout design. If we go to new and browse templates, we must ensure that we are in the standard IAM file. I'm going to choose millimeter as metric. Now once that is open, if you do remember on one of the slides, when it comes to the layout design, the first thing we do is open an assembly file. From there, the layout will create an IPT, and from the IPT we'll start creating all our individual blocks and then all our individual components or parts, depending on what is needed or required. Now for instance, in the assembly tab, we can go to the component and make a layout. Here you can give it a specific layout name for the layout. So I'm just going to call this layout design web, and then you can utilize what type of template you want to use. So you can go into your drop down depending on how your Inventor was set up, but I'm going to go and browse for a metric template, and that's going to be standard millimeter IPT. Here you do have your location where it's going to save that entity, and from here you'll say OK. Now you'll notice, as I mentioned earlier, that when you create your layout will already be grounded. From here you can go and start your 2D sketches and start utilizing all the different types of constraints, blocks and environments to drive your constraints. You can also set up different types of parameters as needed or required that can fully drive your 2D skeleton model. So from here I'm going to go into start 2D sketch, and I'm going to utilize my front plane. Now you can start creating your 2D sketches. Now remember, when it comes to creating a layout design, you need to remember how important it is to have your planning that is accurate. I'm just going to draw a normal square block and say that's going to be 20 by 20. And you can see it is constrained. Now here I'm going to create, let's say, a 20 by 5. And now this is where it can get complicated, because you need to remember that you'll need to create your blocks before you can create components, and where constraints come into place is after you have created your blocks. Now in the layout tab, if this tab or panel is not available, you can simply right click on your ribbon, anywhere on your ribbon, go to show panels and ensure your layout is ticked. From there you'll see your layout panel. Now from here I'm going to go and create blocks. First you select the geometry you would like to utilize, and then you can give it a name. Now in this quick example, I'm just going to utilize and say, okay, that I'm just going to call block 1 as an instance. I'm going to say apply. If I say okay, that will close the command, and then I can open the command again to create another block. But in this instance, I know I'm going to utilize the same command, so I'm just going to say apply, and then I'm selecting this geometry and saying apply. You'll see I'm just giving it quite simple names like block 1 and block 2, just to utilize how we can name it, so you can rename it if needed. Going to say apply, and you'll notice the dimensions do disappear. Now from here, I'm just going to utilize a few constraints. As you can see, I want my blocks and my entities to update as needed or required if there's any changes that's made. I'm going to utilize the constraint there and just get that on this block over here, on that center point, and I'm just going to utilize that vertical and horizontal type constraints just to ensure that it is correct and that it's fully constrained. From here you can go to make a part. Obviously it would ask you to save it first, and you can give it your specific name. I'm going to say yes to all and okay. And now from here, when you create your parts, because this is only 2D sketch entities, you have to go into your sketch environment and then go and select your blocks that you would like to utilize. From here you can go and choose your templates and your bomb structure. Now you also do have your derived styles where you can choose between a single body merging, where it keeps the seams between your planar faces, where it maintains each solid as a solid body or as a surface body. The statuses is where it derives the selected objects. You can exclude the selected objects, include bounding boxes if there's any solid bodies or so on, and if you want to include cylinders of the solid bodies. You can also give it a specific name as needed or required. Because I'm utilizing more than one part, I'm just going to ensure that I am still within my sketch, because that is where my blocks are. You can also go and choose make components, where you want to select more than one individual part, because making a part makes one individual part, where components can make multiple parts. I can simply select the two entities, and you'll notice that it does pick up the two different blocks that I have created. From here I'll go to next. Here you do have the option for your component name. Here you do have your template. I'm just going to click on it and ensure that is on my metric. You can choose your sheet metal if you need to or as required. Now in this instance I'm just going to choose a standard millimeter IPT. I'm going to ensure both of them are just a standard millimeter IPT, and you can also set up your bomb structure. If any parameters have been created, you can include the parameters, and I'm going to say okay. And now you'll notice that we do have our two blocks that have been created as components, so each part individually. To simply activate that part, I'm going to double click on the solid body, and I can utilize, for instance, the extrude in this environment. If I'm happy, I can say okay. I can simply double click on the other one and, for instance, utilize the revolve as needed or required. Can do a local update and have my assembly, and you can see it's fully constrained as well. Now from here it is quite easy where you can utilize any changes. As an example, now to make a change you need to activate the layout design. With the layout design you need to activate the sketch, because the sketch is what is constraining or utilizing the whole environment. From here you can go, for instance, into block 1 and make the changes. Click on the update and you'll notice that it quite easily updates the component and part and the solid body. I can activate the assembly and you'll notice that it has updated. That's why it's so important that when you do and create a layout design, that it's so important when you do your planning and ensure with your constraints, so when you make an update that it is updating correctly and not breaking the whole 2D sketching environment. Now that was just a quick example of how a simple layout can be utilized and how effective it is to make a change using this method as an example. I'm going to close this and then I'm going to go and create another layout design, a little bit more detail. So I'm going to again go into the assembly environment. Once I am in the assembly environment, I'm going to go and create a layout again. Now I'm going to call this, give it a unique specific name. Again, I'm going to utilize what template I'm going to utilize, and that would be the standard millimeter IPT, and I'm going to say OK. From here I'm going to go and create 2D sketches. So first of all, I'm going to utilize my 2-point center rectangle, and I'm going to say that is 25 by 25. I'm going to create a circle on this part over here, and let's say that's going to be 10. Now you can go and create all your components as needed or required. I'm actually going to create, let's say, another circle here. Let's say I'm going to make that 5. Just getting this in the correct orientation and constraining it as needed. So I'm making that just 9 at a time. Now I'm going to utilize another block. Let's say this is going to be 12, and let's say that's 35 as an example. From here I'm going to utilize and create a circle there. Let's say that's going to be 4.8, leaving a little bit of gap for any fits and tolerances. So I'm going to give that a distance of 6. Just going to utilize some of the constraints just to get that in the correct orientation. From here I'm going to create another circle. So I'm going to make that 8, utilizing just a few constraints just to get that in the correct orientation. And I'm going to create just another random circle again. Let's say that's going to be 7.8. Now I've got three different entities here, where one is fully constrained and the other two items are not constrained. Now, one of the important things to remember is you need to remember to constrain your parts as needed and required. So if there's any updates that do take place, that it all works in conjunction with the correct geometry and correct constraints. From here, I'm going to go and create blocks. I'm going to select that entity first. I'm going to call that my center block. Going to say apply. Creating that, I'm going to call that an arm as an example. And I'm going to create another item and say that is a pin as an example. Going to say apply, and you'll notice that all the parts have been utilized and created. So I'm just going to ensure that all this is fully constrained. Now what I'm going to do here is going to utilize my coincident constraint and place that on that orientation. As you can see, that is more or less what I'm looking for, and just going to ensure that this part, it is fully constrained as well. Going to utilize the coincident constraint and just ensure that is concentric. If I switch on the degrees of freedom, you can see it can still rotate. So I'm just going to ensure a few things. Now from here, what I'm going to do is I'm going to click on the update, and what I wanted to show you with this example is you can utilize more than one block. Simply open your blocks. As you can see, there's the blocks. You can add another item of a block that has already been created. And I'm just going to again constrain this on the same point. Just going to ensure again that is fully constrained and say finish. Just to give you an overview of what's happening, so I've got my center block, my arm, my pin, and another arm. Now I'm going to go into the sketch environment because I want to make my components. So I can go and say yes, I want to save this assembly, yes to all, and say OK. Now I can go and select all the parts that I would like to create. Say next. Now you'll notice it's only showing one arm. Remember, it's the same arm, same entity that I'm going to utilize twice in the environment. From here, I'm going to go into my template. Just going to ensure that they're all on the standard millimeter templates. Just doing that with all three items, ensuring they're all on metric. You can choose your bomb structure as needed or required, and I'm going to say apply. Now all those parts have been created, so I can go into my center block, choose to extrude that block as needed or required. I'm going to say in both directions. I'm going to go into my arm 2 and I'm going to extrude that. Let's say I'm making that 2 millimeters thick. I can choose the sketch plane from here and say OK. Just going to minimize some of my browsers. Now when we go to arm 3, remember it's exactly the same part, and you'll notice that there's already a few things that have taken place. If we go to our origin, there's your layout, and there's your different blocks and your different views as needed or required. If I go into my assembly environment, you'll notice there's already a constraint that has taken place. So I can go into the second arm and right click, choose edit, and I can give it an offset value. Now I already know it is going to be, for instance, 12 millimeters, just to give you an update what would happen. Let's say that's going to be 12. As you can see, it's utilizing and bringing it into this environment over here. So it's placing the block right next to that specific block that's needed or required. Going to use 0 again, just so that you can see. And if I go into all the different types of the layout, you'll see all the different types of constraints that was utilized. So I can go and create an offset there as well, and you'll notice that it puts it on the opposite side. So this is one of the great benefits of using this type of environment. It would create the constraints and the different types of constraints, like your mates, your offsets, everything individually as it's drawn by the sketch and driven by the geometry that have been created. Going to go to the pin. I'm going to utilize the extrude in both directions, and I can give it a specific value, let's say 16, just as an example, or let's say 18. I can go into the update, go into my main assembly, I can go into this sketch over here, I can right click on it and switch off the visibility of those sketches as needed or required. If I go to my home page, you'll see there I've got my assembly as needed or required. Now you can go and create, for instance, another pin over here to get it through the block as needed or required. And you can go and make your changes. Now this pin, it's not 100% fully constrained, as we saw with the degrees of freedom. It gave us a rotational value that it can still move in a rotational axis. This has been created from the same as that, and this is driven by all the different constraints. And I created an offset value on that XY flash constraint on that plane, offsetting it to the different type and the different side of the block. And it's quite easy. If your drawing is fully constrained, from here you can go and make your changes as needed. You can also include any type of parameters that is needed or required to drive your sketch. Now again, this is just an easy example, an easy sketch, easy model, as it can get very complex. One of the most important things to remember, it is when you are utilizing the layout design and creating your 2D sketches, that it's very, very important to remember about the geometry and the relationships that have been formed. For instance, if this block has to change thickness, that offset value will need to change. So it is quite important to plan and plan and plan. It's something I can't say enough because this can get very complex. This is just a simple model with a few small parts and not too complex. Now, when we think about the summary of how to utilize the layout design, it comes back to the key features, the advantages and disadvantages. Planning how to utilize your constraints, how to utilize the blocks and the environment, creating your components, selecting the correct templates, going into your bill of materials as an example, you'll see that there's no previews of certain parts that is available. And yeah, if I just open this up, you'll see I can go to the parts only, enable the BOM, and you'll see there's no part numbers because it hasn't been set up in the iProperties. Again, you can go into your column choosers and select your columns that you would want to utilize. Let's just open on my other screen. So here you can go and customize and insert different port or different columns as needed or required. So I just inserted the file name, and as you can see, the arm that I utilized twice does show correctly in the bill of materials, although there's no thumbnail available, but it does open up within the bill of materials as well. So at the end of the day, it comes down to what you want to achieve, what you are looking to design, the standard that is in place within the company. Very important, remember the relationships and the geometry that have been created within your sketch. Just to recap, this would be your layout, and to make any changes or modifications, you need to ensure that your layout is active, your sketch is active, and whatever you want to change, to make sure that is the active part. Thank you guys for watching and joining the webinar this morning. If you have any questions or would like to reach out to us, you can please email us at info@mgfx.co.za. You can visit our company page at www.mgfx.co.za. Thanks for watching. Please like and subscribe and follow for more content.